Going over parallel lines cut by a transversal here. Super important lesson for not only Unit 2, but the rest of geometry. So make sure you got your notes out to write down these important vocab words coming up. So when we have parallel lines, over here are parallel lines, over here are two not parallel lines. And we have a line that hits them both. That's called a transversal. Just open the class with what do you notice, what do you wonder? Well, if the lines are parallel, these four angles always match up with these four angles. So 141, 39, 141, 39. Same thing over here. And I can move that all around. Even if the angles change, 56, 124, still matches up when they're parallel. If they're not parallel, the angles do not match up, right? They are not equal, right? We got 132, 132. The vertical angles are equal, but they're not equal down here. The only way to have all those angles match up is to get your lines parallel. Ooh, now my lines are parallel. My angles match up. All right, so did a quick partner practice. I'm going to show you a quick one. So if this angle was angle A and these two lines were parallel, right, what angles are congruent to A? And we just had to click them. There's the vertical angle. And then if we come down here, we want to pick the ones that match. So A is the bottom right-hand corner. So bottom right-hand corner. Oh, and the vertical angle. So those four angles are equal to A. If the lines are not parallel, the only angle equal to A is the vertical angle. This angle is smaller. This angle is smaller. If they're not parallel, they don't match up. That's the big idea here. All right, I'm going to skip ahead just to save time. So some big vocab words. First one that you want to write down, pause the video if you need more time, a transversal. A transversal is a line that intersects two or more lines. So looking at this diagram, P is the transversal. It hits line L and M. Transversal just hits two lines. That's pretty much it. Corresponding angles are angles that are matching or in the same spot. So for example, if I looked at, there's four angles here. 1, 2, 3, 4. Angle 1 is like the top right-hand corner. It's acute, it's kind of small. So if I came down here and looked, top right-hand corner would be right here. So the corresponding angles are in the same spot. And when two parallel lines are cut by a transversal, those matching angles are always equal. Maybe it's like 40 degrees. So this one would also be 40 degrees. Next big vocab word is alternate interior angles. I'll give you a tip in a second. It's going to be confusing, but I promise I'll give you a pro tip that'll make life easy. Alternate interior angles happen when we have two parallel lines cut by a transversal. The interior, it's like inside the parallel lines. And alternate means it crosses over to transversals. So here's the transversal. So one's on this side on the inside, one's on this side on the inside. We call these alternate interior angles. And they're always congruent. And an easy way to remember this is if you have parallel lines, if you made a Z, you make a Z, right? The corners of the Z are equal. So maybe this is like 50 degrees, I don't know. Just making up a number. So this one is also 50 degrees. Now, just one little thing. If you made a backwards Z, it would still work. So I'll do it. Let's do orange. If I made a backwards Z, these angles, these corners of the Z are also alternate interior, but they're not 50. Those would be 130. 130, 130, if I was using 50 as the other example. All right, so corners of the Z will help you find the alternate interior. So just a quick teacher example here. If I have two parallel lines, L is parallel to M, I could draw those arrows to show they're parallel. Determine the measure of angle X. Well, this angle is 98. Let's use the Z. Let's use alternate interiors. Okay, so this 98 is also here, right? Alternate interior. So it's not equal to X. They make a straight line. So X plus 98's got to equal 180. All right, 180 minus 98. Let's see what's left. That angle has to be 82 degrees. So I can use these angles and their definitions to figure out missing angles.